Testing, testing. 1, 2, 3. Hi, Skylar. How's things?
Morning.
Oh, good. I thought you couldn't hear me. Good morning. I was saying, how are things?
Oh, so far so good. Just working on 7.3.
Gotcha. How's it going so far with those? The ones you've done at least, not so much 7.3.
So far I think it was pretty good.
You getting the answers that you'd expect to get?
Yeah.
Well,
So.
there's always going to be a couple.
Yeah,
That's the way things are.
Yeah, I just know I'm doing something wrong on the current problem, but I don't know. I'm just trying to make sure all my numbers are right.
Yeah, I can. Something
They
simple like that.
I ended up finding out I was just mixing up the numbers.
Gotcha.
But yeah, everything else looks so far so good. I'm just hoping it sticks and I remember it.
Yeah, there is a heck of a lot of formula that you need to know, and well, not so much memorize because there are too many probably to do that, but that you need to know so you can use them. So are you on the double angle one now?
Yeah.
Right.
I got the first one. It was pretty easy and straightforward after I got the numbers all correct, making the triangle. But now making the triangle for the second one is proving to be a bit more difficult.
Right. The only another thing you could get caught out with when you do those questions is plus and minuses. So pay attention to what quadrant the angle is in. So if it's in the second quadrant or the third, that might make an answer 3/5 turn into -3/5, for instance, and that can catch you up.
That could be it then.
Right.
So I'm in the second quadrant right now, so I guess that means...
Well, depends if you're looking for a sine or a cosine.
They gave me the, was it the secant?
Oh, well, you have to do the reciprocal of that and turn it into a cosine, and then start building your triangles.
I got the cosine part correct, but
yeah,
trying to convert it into the sine and the tangent, and it's not giving me the fraction that I was looking for.
Well, hold on. What's happened to this darn thing? Is that sideways? That is sideways. How are you doing on?
Pretty good.
You still got your San Francisco Bridge, I see.
Yeah, I think I'm going to stick with
it. Yeah. Well, let's see what I got. I haven't started yet. And can I change? Well, maybe I can't. Let me check. I'll record this one. That way, if someone misses it, at least they've got something. Right, are you all looking at the main screen? Right.
Yep.
Okay. Yeah. So you might be asked to find the exact value of 75 degrees. Right, you've seen a question like that. Find the exact value, the cosine of 105, things like that. In these questions, your strategy for doing it is to find two angles that either add up or if you subtract them, get you 75. But it can't just be any two angles. You can't just say 60 and 15. The two angles must be on your unit circle, right? They must be in the unit circle. You can't use them if they're not. Has anybody got a combination that would work for this one?
Me? Is it?
Anyone?
Yeah.
Is it pi over 4?
Oh,
well, let's do it in degrees.
what?
Okay. What I'll do is I'll mute you all, and that way you only need to, if you want to say something, you can kick in. So that'll save us over hearing, over speaking over the top of each other. So, two numbers that add up to 75. Any volunteers for a combination that would work? There's I can think of two, but there's probably more.
45 and 30.
You agree? Add up to 75, both in the unit circle. And that's just the first hurdle, and it's an important hurdle. I think the textbook calls it S and T, don't they, when they say the sine of S plus T and so on, right? So just to be consistent, I'm going to call this S, I'm going to call this T. So what we're really looking for is the sine of S plus T. And then you have to go looking, because these two sections are full of formulas. And this is called the addition formula. And it's the sine of S, cosine of T, plus cosine of S, sine of T. And so far, so good. Now that becomes the sine of 45 degrees multiplied by the cosine of 30 degrees, plus the cosine of 45 degrees times the sine of 30 degrees. So what I've done there is I'm taking this two things added, calling the first one S and the second one T, then using the formula for the sine of S plus T, the addition formula it's called, and then replacing the S with 45 and the T with 30. Now each one of these four pieces, I know its exact value because they all belong in the unit circle. So for instance, the cosine of 45 ends up being root 2 over 2. The cosine of 30, now isn't that the x coordinate of the 30 degree guy, right? And that's root 3 over 2. And the cosine of 45 happens to be that fella, and the sine of 30 ends up being, I believe, a half. Now you multiply these together and you get root 6 over 4. And you multiply these together and you get root 2 over 4. So the whole thing comes together like that. Are we comfortable with the general process? To me, there's two stages. The first stage is to figure out how to write this guy as two guys added. Now, the cool thing is, it doesn't matter which two guys you add or subtract. As long as they end up being 75, it will work. So, I mean, 45 add 30 is pretty straightforward, but I mean, if you thought hard about it, you could probably get some angle, take away another angle that would also get me 75, right? I could do, I'll try to think of one off the top of my head, 135, take away 60. No, yeah. Yeah, 135, take away 60. Do you know both of those are in the unit circle? But it would be a subtraction, in which would 135 take away 60, that would be 135, and that would be 60, and there'd be a minus in here because the formula changes. But, strangely enough, there's only one correct answer. So no matter which pathway you get, you will still finish with this answer. So when you plug into the box, they don't really care which one you did. Now that one was for degrees, and I think it's easier to do degrees because you can see combinations in your head much quicker on the unit circle. Now I'm going to do a very, see if I can get this focused a bit better. Now we're going to do some example where we use radians. Now radians cause an extra level of problem. When you go and you do your unit circle, you're going to get pi upon 6, pi upon 4, pi upon 3, and over here it's going to be 5, 6 pi. That guy there is going to be 3/4 pi. And the guy that goes here is 2/3 pi. So what's the added problem? You've got to find two angles that add or subtract to give you -15/12 pi. But these angles are all different denominators. So I suggest that since we're dealing with twelfths, is this one going to be 8 twelfths? Is this one going to be 9 twelfths? This one here is going to be 10 twelfths, and so on and so forth. So what we're looking for is using these ones, right? The blue ones, because then it becomes a little bit easier. Because everything is in twelfths, aren't I just looking for two guys that add to give me 5 twelfths or subtract to give me 5 twelfths? Now I get an extra clue. Do you notice that this answer is a negative number? It's negative 5 twelfths. Doesn't that mean that you're going to have a little guy take away a bigger guy? Because that's the only way you're going to get a negative number out of it. So I'm looking for two guys. They're actually in this list. If you take the first guy, are they in this list? Yes, they are. Just double checking. That you take the first guy and subtract the second. Olivia. Yeah.
4 pi over 12 and 9 pi over 12 minus 9 pi over 12.
You agree? And we get a couple people just coming in. We cool with that? Right now, that becomes the cosine of, we'll call it S, take away T, because that's the guy. You might want to get a little printout or write down all these guys so that when you're about to do the question, you can just look at the paper. Otherwise, I guess you're going to have to go and hunt through the ebook to find the formula that you're looking for, and it's going to slow you down. So have, the sine of the sine and the cosine especially at handy. So this is cosine S, cosine T, plus, I know that sounds wrong, but it isn't, the sine of T, sine of S, sorry, the sine of T. Strangely enough, the cosine of two things subtracted has a plus in its formula, which is kind of weird, but it is. So what do I get here? I'd get the cosine of this fella, which is really a third pi, followed by the cosine of this guy, which is 3/4 pi, plus the sine of this fella, which is back to being 1/3 pi, and the sine of the other guy, 3/4 pi. And then, you just do some numbers and you're finished. Yes, Owen. Can't hear you, Owen. You want to say your
Where'd
question?
you get those numbers?
Which ones? The thirds and the
Yeah,
3/4? Oh,
yeah.
The guy, the choice that we had was this guy, take away this guy. 4/12 is pi over 3, and 9/12 is 3/4 pi. So that's where they came from. Now,
Okay.
right, so what I did is you took your unit circle, but we turned everybody into 12ths to make it a little bit easier to find what combinations work. Then we found a combination that worked, which was 4/12 take away 9, because when you subtract them, you get negative 5/12. But 4/12 and 9/12 were only there to help me get to here. It's much better if you use what they are in the normal unit circle. So for instance, that's a third and that's 3/4, and off you go from there.
Okay.
So hold on a second. I'm going to put in Conrad and Keelan. Right. Okay, so that was the first type of question that you see in this section, right? Find the exact value of 75 degrees. Find the exact value of the cosine of negative 5/12. The next kind of question that I'm going to deal with from that section. And then I think what I'll do is I'll pause and you can ask me any homework questions from that section. And then we'll kind of say that one's done and move on to the next. So in this question here, you're going to be given something like this. The sine of x is 3/4. And do they use x's or thetas? Does it matter? And it doesn't matter to me, but I'd like to be consistent. Let's find the question that way. I don't know. Okay. I'm going to call them x and y then. And the cosine of y is, say, 1 over root 3. And x is in the first quadrant, and y is in the fourth quadrant. So that's what you're being told. And you're going to be asked, perhaps, to find the exact value of the sine of x add y. So can you imagine how this is going to work? Well, the formula is the sine of x, the cosine of y, plus the cosine of x times sine of y, which in this question becomes, oops, the sine of x is 3/4. The cosine of y is 1 over root 3. And then we got a problem. We do not know what the value of these two things are. And somehow or other, we're going to figure out how to get the value of them. Right? So let's take the first piece of information. If you tell me that the sine of x is 3/4, according to SOHCAHTOA, isn't the sine the opposite over the hypotenuse? And so I should be able to build a little right angle triangle. Me personally, I don't like x's and y's in these questions. I like theta, because to me, x makes you think x coordinate. But it's nothing to do with the x coordinate, it's just a placeholder for a missing angle. That's just me being awkward. So opposite, adjacent, hypotenuse. And we know that the opposite is the top number, and we know that the hypotenuse is this one. So to get the adjacent, don't you just use Pythagoras? And it's not a nice number, but mostly they're never going to be nice. So 16 taken away 9 is the square root of 7. Now, that is going to allow me now to find the cosine of x, because the cosine of x is the adjacent over the hypotenuse, which means it's root 7 over 4. Right? Adjacent hypotenuse. So this fella here is going to be root 7 over 4. Now there's something I could have forgotten, but I just remembered in time. You have to take into account the coordinate, the quadrant that the angle is in. Angle x is in the first quadrant, so doesn't that make the cosine positive? So that's perfectly fine. But see if this had been in the second quadrant, for instance, the cosine would have been negative, and I would have called that negative root 7 over 4. So be on the lookout. Pluses and minuses can kick your butt here. Let's do the y one. I know that the cosine of y is 1 over root 3. And I know that's the adjacent over the hypotenuse, so I'll build my triangle again. There's my adjacent, there's my hypotenuse. 1 over root 3, and I believe this guy here is root 2, using Pythagoras. So now that I've got that set up, I should be able to get the sine of y. Well, that's opposite over hypotenuse. That's root 2 over root 3. So far, so good. Now, y is in the fourth quadrant. Is the sign positive or negative in the fourth quadrant?
Negative.
Which means this guy is a negative root 2 over root 3. Now you multiply the top two together, you get a really ugly looking thing that looks like that. If you multiply the other two together, you get another equally ugly thing that looks like that. But you notice it's now negative because two plus and minus. That gets me our final answer. Now, there are a couple of things you can look for that tell you if you've gone wrong. Whenever you do this kind of question, do you see these two guys here and these two guys here? They're always going to be the same pairing. So if I've got a 4 root 3, I'm also going to get another 4 root 3 over here, right?
Someone was asking, how is it in the fourth quadrant?
It's in the fourth quadrant because you were told that in the question. Why is it in the fourth quadrant?
Gotcha.
Right. So if you're not told, the question's not fair because you can't answer it, right? Because you need that information. So you see how that puts together? Good. Okay. That's everything I want to cover, but that doesn't mean that's everything we're going to cover. Is there any homework questions from that section that you'd like me to go over? And I'll do that right now.
Yeah, I had one.
Okay, what is it?
Sine of
What no-
7x plus cosine of 7x. And
Right, oh, right, start again. I'll write it down.
Okay.
What is it?
It's cosine of 7x plus sine of 7x, and you have to express both in terms of sine.
Ah,
I always get that part. I remember
this fella is pure math. There is a formula that allows you to add a sine and a cosine together. Now, you probably won't ever memorize it. I certainly haven't. So what I'm going to do is I'm going to spend a few seconds and go and get that textbook and show you the formula that I'm about to use. I'm calling it A and B, but who knows what letters of the alphabet this textbook's going to use.
sine of
Trying.
7x. I didn't know. If I said the sine is also 7x. I'm sorry.
Oh, this one here? That was...
Both cosine of 7x and sine of 7x.
Oh, and this is 7x?
Yeah, they are both 7x. So it is cos and a sine. Sorry.
Okay. So we have a sine of 7x plus the sine
Oh no,
of
cosine
another...
of 7x. Sorry. It's a sine of 7x plus a cosine of 7x.
Okay. Actually, I could have left the original because it would have been the same result, but it's fixed. Let's... you can't see it yet, but I'm loading it up. It takes a few clicks and things to do to get there. So we are looking at 7.2. Right. I'm going to get to... Well, actually, let's show you everything. That's probably a better way of doing this. Right. If it would be a good idea if someone could do this for me. If someone goes to the... Because not everybody's got a mic, and I don't always realise that. If somebody could go to the chat from time to time and, like you did, and say, oh, someone was asking this, I would appreciate that. It would help us not miss anyone's comments. Right, do you recognise all these formulas for doing the signs of A's and B's and adds and subtracts? If I scroll very slowly, okay, try quickly. Where are you? I may have missed it. I'm just looking for the formula. I haven't memorized it myself, or I just write it down. But these darn things are hidden in here somewhere. This is definitely from 7.2, agreed? Yeah, so why aren't they got... I know that these formulas exist. So why am I not finding it? That is not Good. They're the people who write this darn textbook. They should have done that. Okay, plan B. I'm now going to go and find that formula that they should have gave you in the first place. You can't see it. I'm writing down sine plus cosine, and with a bit of luck, I'll get the formula for us.
And
Right, we're looking for a sine plus cosine, right?
yes.
Right. Here we go. Oh. You never find things when you want them. I have got every combination except the one that I'm looking for in this screen. Okay. Why? Let's look for another one. If I can't get this, will you just let this one slide so we don't waste time me searching for it? And once I do find it, I'll shoot me an email and I'll just send you back the proof for it. Okay, we got one, I think. Nope. Right. Has someone got it for me? I can't find the darn thing right now.
Daria says it's on the chapter test.
So what is, can you tell me what it is off the top of your head? Have you got it written down somewhere?
Just joking.
Oh.
Could show up in the test.
Oh. Yeah. I wasn't paying attention to jokes. I like jokes too. Okay, forget it. I'll tell you what it looks like. They all look like something like this. That's their generic form. Now, it might be A minus B, A plus B, it might be sine and sine, it might be cosine and sine. That's the problem. There's many combinations. But essentially, you make this A and you make this B, and you plug the 7x for A and the 7x for B, and you half it. So let's just pretend that that's the right one. I've got a 1 in 8 chance that that's the right one.
I get it to show what you're writing instead of the book.
Oh, let me show you. Oh, okay. Imagine this is called A and this is called B. This is the formula. That's what it will look like. So if you want to add a sine of A plus a cosine of B, it looks something like this. What you then do is the sine, that's A and that's B, and you half it. This is a cosine, that's A, that's B, and then you half it. What does this guy get you? If this was true, wouldn't you get 14 halved, which would be 7x? Wouldn't this give you the cosine of 0, which is 1? And you would end up with, if that was true, the final answer would be that. Now, the only part of this puzzle that might be wrong and is very likely to be wrong is this formula. Now, I was spending 5 minutes hunting for the darn thing. See, once you do find it, will you write it down so you don't have to do the same hunting that I had to do? This is the generic version. I know that it will look like this. It will always have a half. It will have sine and cosines. It will have A plus B's and A minus B's, all divided by 2. And you can probably tell why I don't bother memorizing something, because there's so many of them as well. Okay, that was a little bit less satisfying. Oh, that's an idea. This is for me. I'm going to find a PDF that has all of those things in one place, and I'll put it on Canvas, and all you need to do is print that one page, and that'll save you having to hunt for them all as well. So I've taken a little note to myself that that's what I shall do. So hopefully that'll at least alleviate one of our issues. Right, well, any more of the questions not involving sines plus cosines?
I have one from 7.3. Nobody else has one.
Oh, perfect. Well, let's start 7.3 and we'll show you how that's going to work. It may actually be similar to the one you've got. Suppose I tell you that the sine of some angle is 5/12. And I tell you that x is in quadrant 4. No, quadrant 2, because it's positive. You would be asked, typically, to find the sine of 2x, the cosine of 2x, and lastly, the tan of 2x. And it would say find the exact values, right? So no decimals allowed. Right. One of the many formulas that you need to know is that the sine of 2x is 2 sine x cosine x, which I will make sure is on that PDF that you want. Right, so you take that as it is because it is. Right. Now, I'll build my little right angle triangle like I did the other time. I'll call this the opposite, the adjacent, and the hypotenuse. And since the sine is 5/12, that makes the opposite 5, and the hypotenuse is 12. And so I'm going to get, as you probably will get most of the time, a really ugly square root. So let's see what I've got. 144, take away 25, leaves me with 119. So using Pythagoras, I now have this fella. You okay so far? Now, 2 times the sine times the cosine. Well, the cosine is adjacent over hypotenuse. And then I pause. X is in the second quadrant. What's a cosine of an angle that's in the second quadrant? Positive or negative?
Negative.
Right. So that means this fella is negative. So our final answer is negative 10, the square root of 119, all over 24. 2, 5 in square root, and it's negative 12 times 12, and nobody notices that I can't count. 144. Is that the answer? If you plug that into the box, is it going to say check or is it going to say wrong? Look again. Is there anything that you can do to make that a little prettier? Can't you cancel it just a little? And the textbook can and very often is, or the WebAssign very often is, fussy about the form of the answer, right? Do you know if the answer is a half, they don't want you to write 2/4? And so you could do the entire question right, and then all you see is, I'm wrong. And then you think, oh, I've screwed this up. I don't know what I'm doing then. I thought I knew what I was doing. It looked right to me, but it's telling me I'm wrong. So be careful. Now, suppose we now look at how to get the cosine of 2x. It's got a formula, cos squared x, take away sine squared x. Now, I don't memorize the sine of A plus the cosine of B. There are so many combinations and they're so ugly, I just don't. I guess if I wanted to, eventually I could memorize them. But I do memorize pretty much all the others, right? So I know what sine of 2x and the tan of 2x is. and I know what the sine of A plus B is and all those combinations. So that makes, notice how quickly it is to do this. Otherwise, I'd have to say, darn it, I know there's a formula for this, now I'm going to have to find it. So if you've got it at the tip of your tongue like we have here, we're good to go. Now, in this question here, we already know what the cosine is. The cosine is adjacent over that guy, so it's negative this fella over 12 squared. Take away the sine, which is 5/12 squared. Now, although that looks really messy, it's not that bad. You know, a negative, when you square it's positive, and a square root gets you that guy. And 5 squared gets me that guy. So it looks like I'm going to have 119 take away 25, and I'm looking at 94. 144. Is that okay? Right. Now, same answer as before. Is that good, or can I do better?
You can divide by 2 on both sides.
Okay, well, let's do 2 first, because it might be more than 2, but it's a good start, right? 2 into that one gets you, what, 47? Yep, I can't say any better than that. Did you notice in this one I wasn't worried about the plus minuses, because I already had figured out who was plus and minus here. So it was just a calculation for the second one. Now, there is a third one that you're asked, so that's the answer to the sine of 2x. That's the answer to the exact value of cosine. There is a third one in this set. And he does have 2 versions of this formula. There's one that goes tan x plus tan x all over 1 minus tan x squared. Or there is this one, which I like, because it's easier, which is that one. And that is equal to, excuse me, that is equal to the sine divided by the cosine put little brackets around them.
Move it up just a little.
There we go. Sine and cosine. Then cancel, cancel. -5 square root of 119 all over 47. I don't think you can do anything with that one. Call it good. Are we good with that one? Right. Now I'm going to have a look at an identity question, which I think they might have in this group. Let's see if I can find one. No, it's not an identity. Okay, how about this one then? Simplify the cosine of 11x plus the cosine of 8x. And this is question, I believe, question 13. And this is question 13 from 7.3. That's one of those horrible formulas that I can't remember. And I was wrong. It's not 2, it's a half, but I can live with that. That's the formula for it. So even if I tried the last one, I would have been wrong because I had a half when I should have had 2. Call this guy A, call this guy B. So it's going to be 2 cosine 11x plus 8x divided by 2.
Blurry.
Say it again? Say it again, Daria. You're breaking up.
Oh, it's blurry.
It is. And let's get the autofocus going. Come on, autofocus. Anything? I move it. That might give it a. Is it? We're good. Right, thank you. So A plus B is 11 plus 8 halved. That's the other one. Okay, here goes. Add that and that, you get 19 halves x. Take away that, you get 3 halves x. It's really just plug and chug. If you get the right formula, you just plug it in. But I was hoping to find a particular example that had an identity in it, but evidently either I can't see it or it's just not there. Okay. Do one. Yes, question.
I had a question. So
Yeah.
on number 2 for 7.3,
Uh-huh.
it says secant.
Oh,
What is-
good question. Right. So it's, I think it's, in the one I'm looking at, it says 2. Do you have a different number?
Mine is 10.
Okay, let's say it's the secant of x equals 10, and x is in, let's say it's the second quadrant. It might be in the first, but let's pretend it's in the second, right? Now, we're still being asked in this question to find the sine, cosine, and tan bit, right? Maybe what I'll do is I'll just set it up and then, you know, to the bit that you really need, and then say, look, you could probably finish it yourself. The first thing I'm going to do here is immediately change that information into a cosine. Because I only know SOHCAHTOA, sine, cosines, and tangents, right? I don't really try and memorize every other version of SOHCAHTOA that there might be, which makes this guy here the adjacent and makes this guy here the hypotenuse. So in my triangle, the opposite is going to be, the adjacent, sorry, is going to be 1. The hypotenuse is going to be 10, and I believe this is some ridiculous square root of 99, right? Because you always get weird stuff. So far, so good. Now, if you are trying to find the sine of 2x, then it's going to be 2 sine x cosine x. So let's do this one and then just leave the others. 2 times. The sine is going to be, can I change this to the 4th so it makes sense because it's positive? So x is in the 4th. So where we go? 2 sine x. Sine is root 99 over 10. Now if x is in the 4th quadrant, that's what I've changed it to. Will the cosine, will the sine be positive or negative in the 4th quadrant?
Negative.
So I'll stick a negative there. And the cosine of x we already know. And so I'm going to get negative 2 root 99 over 100, which then becomes a single root 99 over 50. And there's our guy. Does that make, is the process kind of familiar, right? And
Yes.
can you imagine the cosine of 2x ain't going to be much of a problem now. And then the tangent's just the first answer, sine 2x divided by the second answer, cosine 2x, and then try and make it look pretty. Okay, so what else have we got here? I'm just scanning through. If you've got a question, that's great. If not, I'll move on. Oh, here's one.
I tried entering just as you did on mine, and same method. It still gave me the wrong answer, so I don't know.
What this one here? What
Yeah,
was your?
I have a -4 from my C camp, but
Okay, so you've -4. Let's zoom through. Well, we only need to check one, right? Which one did it say it was wrong against?
check that. Pretty sure it was. Yeah, it was the sign.
So it was a secant of x equals -4. Is that your starting information?
Correct. In quadrant 2.
And it's in quadrant 2, which is reasonable.
So that cosine is -1/4.
Which is adjacent over hypotenuse.
Yes.
And the adjacent is 1, that is 4, so you should get the square root of 15. And so the sine of 2x, is that the one that you got wrong? Or allegedly wrong?
Yeah.
Right, so that guy is going to be 2 times the sine of x and the cosine of x. So it's going to be 2 times, it's going to be 2 times root 15 over 4. If you're in the second quadrant, that's positive. If you're sine, at least. And the cosine is -1/4. So I'm looking at this fella, which becomes this fella.
Oh, okay.
Did you see what you did wrong?
Yeah, I mean, I was just using the little Desmos calculator thing, and it just gave me a decimal, and I was like, that doesn't make sense.
So you can't, yeah, none of these questions, almost to a T, none of these questions want you to write decimals. So even, you know, if the answer is -0.2345, that won't help you because it'll just say wrong.
Yeah, it
It's got to,
not right.
are we good? Right, now, got a few seconds more, at least I can give you a start to this. You're going to be asked to use the half angle formula to find the exact value of something like the sine of 15 or the cosine of 22.5, something like that, right? And there's a formula for it, like every other formula in the world. And it's plus or minus. I'm trying to find. Oh, darn it. What is the angle formula? It's 1 minus cosine over 2. Now, this is going from memory. So this is the process. Once you get the right formula, you may want to change this, but just so we've got a chance to see the formula. Because if I go online and try and find the formula, our time will be up before I get it. So can we pretend that the formula says this, that the sine of half x is plus or minus the square root of 1, take away the cosine of x over 2. It might say 1 plus the cosine of x over 2, 1 minus the sine of x over 2, or 1 plus the sine. It's got 4 chances. Now, in this case here, 15 degrees gets you 30. So it's going to be plus or minus the square root of 1 take away. What's the cosine of 30 degrees? So it's the x coordinate of 30 degrees.
Square root 3 over 2.
Yep. All over 2. So can I just scrub that out because it's distracting the heck out of me, right? So we got this guy. Now, if you type that in, you're not going to get anything because it's still to be tweaked. So here goes. Which quadrant is 15 degrees in?
First one.
Right. So won't the sine of 15 be positive? So it's not a big change. I'm doing it slowly. You got that? Now, do you think that the textbook's going to be happy with an answer that looks like 1 take away the square root of 3 over 2 over 2? Correct. They are going to want you to do something like this. multiply top and bottom by 2, and you get 2 take away root 3 over 4. So what I did is I basically took the top and multiplied everybody by 2, and and get rid of the 2 part. Great. Now, that is much prettier, yet it's still not going to be the answer at the back of the book. Do you know if you have a square root of fraction, can't you take the square root of the top and the square root of the bottom separately? So the square root of 4 is 2, and that, as weird as it looks, is the answer. Or that, but I'm pretty sure the book will accept both. And I just had a look at the answer. Out of all the combinations I could have picked, I actually picked the right one for this one. So that was just sheer luck. No, I didn't know it. I knew the general format, but I didn't know it. Okay, so we've got a few minutes left, but only really to close up. Is there anything that you want to ask me? And I'm taking a little note. I'm going to put that online formula sheet so that you can have just one place to go looking for all these guys. Hopefully that'll make your life, and probably it'll make my life a little bit easier the next time, because I'll print one out as well. That way I've got it handy when I need it.
How'd you get cosine of 30 degrees again?
Oh, whatever this angle is, that guy's double it.
Oh, okay.
So if this is, I don't know, if this is 22.5, that guy there will be 45. And it's called the half angle formula. So if you want to find the exact value of some weird answer, just double that number and stick it inside. They're not that, actually there's not that many half angle formulas that are worth doing. Right. 15 degrees is worth doing. 22.5 degrees is worth doing. But you don't need to do 60. You know, oh, I'll use, 60 and double up to 120, because can't you just get 60 out of the unit circle anyway? So about half of the questions you could be asked aren't really sensible, because you know the answer to them from the unit circle anyway. So when you look at the half angle formulas, I'm doing a little count in my head. There's only 8 questions in the universe. There's only 8 of them that you can actually do this to, because all the angles that end up here, right, this guy here, they must be in the unit circle, or else you can't get an exact value. Okay, we should finish with a joke, shouldn't we? Did I tell you the one? Because I probably have, but anyway. What do you do if you get attacked by a group of circus performers?
What?
You go for the juggler first.
I think you have told us that one, but it
Really?
gets no less funny.
You like that one, Ashley? Riley, you're not saying much. Did you like that? Oh, I've got tons of chat questions. Darn it, I apologize.
Oh.
Oh,
You're good.
yeah.
Okay.
Right. Let me go through some of these questions that people have asked.
No.
Yeah, you could get that question that we are having trouble with, but remember, you'll have a printout of the right formula to use by then, so it won't be anywhere near as bad as it looked like when I was doing it. Someone asked me to drag my paper up, but that's good because someone else said it for them. I think that's it. That's all the questions I really need to answer. Okay, bye-bye, guys. It was nice seeing you. Usual, drop in anytime. Shoot me an email. Skylar, I think it was you that had that question, or somebody had the question where I didn't get the right formula.
Yep.
The sine plus cosine. If you can, because I'm going to go straight to another meeting, if you could shoot me an email with that question,
Will do.
as I promised, I'll get it done for you, okay?
Absolutely.
Right. Bye-bye, guys.
Later.
Bye-bye, Daria. Bye-bye, Riley.